Okay, good evening, guys. Sorry for the delay in this. I'm trying to do it as fast as we can. So the first question is from 8.1. If I can get my pen to work. The maze completion time of 14 standard lab mice, and then the maze completion time of 14 lab mice bred for higher metabolic rate. So they're different mice, so that means it's independent. If it was the same group of mice, then it's that dependent. I'm going to clear the slide so I can go up and work our next one. So here is the next one. So this one's a little further back in our memory. Okay, so here our first step is use the given sample statistics. They're independent samples to test the claim about the differences of the two population means at a given level of significance. So our claim is mu1 is greater than or equal to mu2 HO AHA. So AHA is the complement. So when we see this, we have these two. We know this one's our claim. I have my alpha out. Alpha equals 0.005. I have my Z naught being. And then this is our calculation for it. So you have x1 minus x bar 2 minus mu1 minus mu2 all over. And then here you have the S1 squared over N1 plus S2 squared over N2. And when we look at this, we see that we end up with x bar 1 up here, 1.28 minus my x bar 2, the 1.34 minus, and this part's always 0 in each one of these. So we're assuming that there is no difference, so therefore it'd be 0, all over the square root of S bar 1, which is 0.30, not S bar, S1, squared, all over N1, which is that 96, plus 0.23 squared over 85. And when we do this, I could show you the other step. I have it down, but I'm just going to jump to the end. I end up with negative 1.519. So when we look at our alpha of that 0.05, we end up with our distribution looking something like this, with this being our negative 1.645, shaded in regions over here. Our negative 1.5 is over here, negative 1.5. It is not in that region, so what do? We fail to reject HO, and we say there is not enough evidence to reject claim. So I'm going to box that part in. So this is the last part. It's going to be worth some points. This part here is worth some points. And then you'll see this part here I get points for, and this part here I get points for. So if you have all of these, you'll earn like 7 or 8 points on this test. Okay. So our question like this on the quiz was a little more confusing for you guys. So in a fast food study, a nutritionist finds that the mean calorie content of 36 randomly selected Wendy's fish sandwiches is 480 calories with a standard deviation of 32 calories. The mean caloric or calorie content of 41 randomly selected Long John Silver sandwiches is 470 calories with a standard deviation of 54 calories. At an alpha of 0.05, is there enough evidence for the nutritionist to conclude that the Long John Silver sandwich has fewer calories than the Wendy's? So I started by defining all of my parts. So I let myself know that mu1 I assigned to Wendy's, which means that the x bar 1, 480, goes with that. The S1 of 320, or 332, sorry about that. And we have an N in there of 36. N1. Our mu2 is going to be Long John Silver's LGS, RJS, and that's going to be x2, which is 470, our s2, which is going to be 54, and then your n in this one is 41, and 2 equals 41. Okay, so now that we have all of this, we can start looking up our thing. So the key part here has fewer calories than the Wendy's sandwich. So for that to be fewer, we want Wendy's to be more than Long John Silver's. That's my claim. HO over here. That's going to be the complement to this, so H1 is less than or equal to mu2, everything else. So again, you want your Long John Silver's to be less than your Wendy's. So then we go to our back and we look for our value that's associated. This tells me it is a right-tailed test. So I know that I'm going to end up with my graph like this over here. We got to find that out. And when you go to the back of the book, you see that Z0 equals 1.645. Now I got to calculate our standardized test statistic. So Z equals x bar 1 minus x bar 2 minus mu1 minus mu2 all over our S1 squared over N1 plus S2 squared over N2. Substitute in what we have, you end up with 480 minus 470 minus 0 all over the square root of 32 degrees, or 36, it's not degrees, squared, plus 54 squared over 41. When I ended up doing this, I got 10 equals or over square root of, that looks funky, let's go here and just, okay, equals 99.566, which is approximately 1.002. Okay. So is that inside the region? Well, we see that it would be like right over here, 1.002. It is not in the region, so what do? We're gonna, for number D or letter D, you're gonna fail to reject. And then for our interpreting this, that's when we look back at that table, we see that there is not enough evidence to support the claim. So there is not enough evidence to support the claim. Okay, we're on to 8.2. Now you have your claim of mu1 equals mu2, alpha equals 0.05, and then we have all the same information but already given to us. You see here that your S1 and your S2 are not equal. So then we're going to be using a slightly different formula this time. So you have HO, our null hypothesis of mu1 equals mu2. Means my alternative hypothesis is the complement. Mu1 does not equal mu2. My degrees of freedom equals N1 plus N2 minus 2, which gives me 29. And then I have to use my degrees of freedom and my alpha. And we know that this is not equal to, which means that's a two-tailed test. So my T critical value is going to be plus or minus 2.045. So now we have to use this nice huge formula. So we have T equals x bar 1 minus x bar 2 minus mu1 minus mu2 all over. And then I have a lot happening underneath this. So we have the square root of n minus 1 s1 squared plus n minus 2 minus 1 S2 squared all over N1 plus N2 minus 2. And then we have times the square root of 1 over N1 plus 1 over N2. So substituting in information, you have 300 minus 290 minus 0 all over And then you end up with 19 minus 1, which is 18, times 26 squared, plus 12 minus 1, which is 11, times 22 squared. All over, and then it's my degrees of freedom, which is the 19 plus the 12 minus 2. 19 plus 12 minus 2, which we've already done, times the square root of 1 over 19 plus 1 over 12. When you do all of this, you end up with 1.104. Once again, I recommend you doing this in different parts of your calculator. I'm going to change my color. So when we do this, then we decide is this in the rejection region. So if we drew this out, you were here. You ended up with 2.045 over here, negative 2.045 over here. Where is that 1.04? Well, it's going to be in the middle. So apparently I gave you a lot of failed to rejects. Failed to reject. And what we say is there is not enough evidence to reject the claim. I hear the thunder outside. I'm hoping I can beat this. Okay. 9.3 or 8.3. 8.3, you have your mu sub d, and you have mu sub d, so my alternative hypothesis is what's given, is my claim. My null hypothesis is going to be the complement. I have an alpha of 0.01, and degrees of freedom, in this case it's n minus 1 of 24. You see here that this tells us it's a left-tailed test, which means that my t over d bar minus mu d all over s sub d over square root of n is going to be 3.2. Remember, we assume that there's no difference, so it's a 0 over 1.38 all over the square root of 25, which we know is going to be 5. And this gives me 3.2 all over 2.276. And I got 11.594. So if this is a left-tailed test, and then you know that it's negative 2.492. It's a negative out front. Sorry, it looks weird. So let's fix that. Okay, negative. So that's over here. 11's way over here. It's probably not even accurate. It should be probably further over. So we see it's still in the fail to reject. HO. Okay, number 6. This is when we're going to need a table. I've already started my table on the computer because it's going to be easier than me actually doing the whole table with you guys. So our first part here is identify your null and alternative hypothesis. So a medical researcher wants to test the effects of calcium supplements on men's systolic blood pressure. In part of the study, 10 randomly selected men are given calcium supplements for 12 weeks. The researcher measures out the men's systolic blood pressure at the beginning and the end of the 12-week study and records the results in shown below. At an alpha of 0.1, can the researchers claim that the men's systolic blood pressure decreased? So you want to show, it helps if you put it into writing, that there is going to be a decrease. So because you want your first number to be bigger than your second number. So when you subtract that, you want it to be a positive number, which is why it's our HO. I wrote that weird, so let me try this again. I got distracted. HA, which is our mu D, because you want your bigger number to be the before, because you want it to lower it. Our second one is HO, struggle busing it, and that's going to be the complement, mu D is less than or equal to 0. That would be if they were the exact same or that it was higher after, which would definitely not be a good thing. So then this is where you use your t-table, and you look in the back of the book, and the value you should arrive at should be 1.383, and this tells me it's a right-tailed test. So over here, okay, so with this, I now have to go to another portion. So give me 1 second. I'm going to scroll over here. You see this is my number 6. I already got it started. I created a table for my x values, my y values. I put the bold as the sums. So my sum of my x, the sum of my y. The difference, that's difference is x minus y. So you can see my formula up here in the top. And then this is d minus d bar. And you guys have really been struggling with this. D bar is just the average. So you just add up all your d's and divide by the number. So in this case, there's 10. So you end up with 50 divided by 10 is 5. So then each of these is just the number d and then subtracting your d bar, which is 5. And then the sum of that is 0. And then over here, this is the quantity of d minus d bar squared. And then this is the sum of that value. So with all of that, we now know that d bar equals 5 because it's 50 divided by 10, which gives you the 5. And then you want to find your s sub d, which is the sum, or square root of the sum of the d minus d bar squared, which is 688 all over n minus 1. And in this case, that is your 9. And so you end up with 8.743. And then we have to, that is the rest of C, question number C. I'm going to change colors so you can tell that I'm working on something else. Number D, or letter D, you need to find your T, or your test statistics, so your T value. So that's D bar minus mu sub D all over this S sub D all over the square root of n. So D bar is at 5 minus 0, because remember we assume no difference, over the value we just calculated, all over the square root of 10, because our total number, which is 5 over 2.765, which gives me an approximate of 1.808. So when we do this, and I wish I could go back to my other slide because I can't pull it up, and I drew out the distribution. Well, mine's not letting me draw. Okay, there we go. And you ended up with 1.383 over here. Is this 1.8 inside of it? Well, we see it is, because 1.8 would be over here. 1.8. So what do we do with that? We're going to, and this is number E. I'm going to draw a little box here. E tells us to reject HO. And then F tells us there is not, or there is enough evidence to support the claim. Okay, I know it's a little jam-packed in there. Now we're back, not to now, sorry. Now we're back over here. Okay, this is a big one too. I wonder, well, that'll be okay. Okay, so now we want to test the claim about the difference between two population proportions at the given level of significance using the sample test. Assume that the sample statistic is independent samples. Okay, so when it does ask you these questions, it wants you to still go through all these. So just like I'm doing, HO, HA, we see HO is P1 equals P2, which means HA is going to be the complement, which is P1 does not equal P2. With this, we now have to find our critical value. So this tells us two-tailed. Ooh, that's ugly, two-tailed. Okay, so when we look in the back of the book with this, we see our Z naught equals plus or minus 1.96. And then we have to find other elements of this to solve the problem. So we're going to start with P bar. So P bar here is equal to x1 plus x2 all over n1 plus n2. So x1 is 425 plus 410 all over 840 plus 760. I'm saying the words, they're just not writing down. Okay, which I calculated to be 0.622, double check that. And you know that Q bar is just going to be 1 minus P bar, which is just going to be 1 minus 0.522, which gives me 0.478. So I'm going to scoot up here to finish my calculations. I'll change my colors. So now I want to calculate my z value, which is p hat 1 minus p hat 2 minus p1 minus p2 all over the square root of p bar q bar for 1 minus n1 plus 1 n2. Okay, which is 0.506 minus 0.539 minus 0, because we assume there's no difference, square root, and then you have the 0.522 times 0.478 times 1 over 840 plus, I'm really getting to the edge, 1 over 760, which gives me something like negative 0.0033 all over the square root of 0.000624, which is approximately negative 1.320. And we see that that is not inside the shaded region. Should you draw this out, and you see that it's going to be negative 1.96, positive 1.96. The number we got is negative 1.3. Negative 1.3 is going to be like right here. So we fail to reject. Okay, finally we're on chapter 9. But this brings with it more tables. So with this one, I did not finish completing it without you. I began with the scatterplot. This is going to be a rough looking scatterplot because I'm just going to try to get it done. So here we have cavities. Over here it goes up by 0.5, 1.0, 1.5, 2.0, 2.5. There's a decimal point between there. And then over here we have 2, 4, 6, 8, 10, 12. And this is sugar consumption. And then it's in kgs, kilograms. Okay, so when we do this, our first part here, you see that you have 2.1 and then it's 0.6, 2.1, 0.6, so it's just right about here. And then you have 5, which is between 4 and that, it's 1.51, so it's just a little bit above here. Then you have 6.3 and 1.55, so just a little bit more. And then it's 8, nope, then it is 6.5, 1, 2, 3, 6.5, and 1.7. So 6.5 and 1.7, 7.7 and 2.8, 1.8, 8.7 and 2.1, and then 11.6 and 2.7. So it's a little rough to look at, but it's going to be roughly that. I have to go to another slide, so we're going to go over here. I'm switching to number 8. So for number 8, I did not do all this without you. I created the X and the Y columns. Okay, then I want to cover up with everything else I need. So I need the sum columns. So I have equals the sum of, and then I want all of this to be included. And then I can drag that over to add up my other columns as we go. And then I want all of those bolded, so control B. Over here, we want these to be multiplied together, so I have X times Y. And then I can drag that formula down to all of the rest. And then we have Y or X squared, so I go to my X, raise it to the second power, and I can drag that down again, and then I have my y. Raise it to the second power and drag it down, which I know you guys don't have this ability right now. You're doing it by hand, but this is a good way just to double check your numbers. So when we substitute this into our formula, we have the formula of r equals n times the sum of xy minus the sum of x times the sum of y, all over the square root, don't forget the square root, that's where you guys mess up, of n times the sum of x squared minus the sum of x squared. I should erase part of that square root. I'll go like this, but we do know multiplying between side square roots, you can combine it, so if I didn't do it, it wouldn't be the end of the world. N times the sum of y squared minus the sum of y squared. Okay, now I'm going to substitute in what I have. So in this case, how many n's do I have? 1, 2, 3, 4, 5, 6, 7. I have 7. Am I going to have enough space is the real question. 7 times the sum of xy. The sum of xy I have is 96.328 minus the sum of x, 47.9, times the sum of y, 12.36, all over the square root. I'm going to wipe this out. There we go. And that's going to be the square root of, it still is 7, the sum of my x squareds, which is 380.9889, minus the sum of my x's squared, so that's 47.9 squared, times the square root of my 7 times my sum of y squareds, which is that 24.536. Ooh, I can tell that I'm going down, so I'm going to go over here. Minus the sum of my y's, which is the 12.36 squared. Once again, that's all square rooted. I did mine in parts when I did it. I ended up with approximately 0.953. So we have r equals 0.953. It's a positive number and it's close to 1. So we call this a strong positive linear correlation. I kept writing it even though it's off the page. Okay. Go back to my review. I needed more space for this. I did not realize it when I made it that I need more space, but I do. So I'm going to just go down. Let's go the whole page. That way this all can be on one page. Okay. So this one here, refer to the previous question. At an alpha of 0.01, is there enough evidence to conclude that there is a linear correlation between sugar consumption and tooth decay? So we already had our HO and our HA, where it was P equals 0, rho does not equal 0, alpha equals 0.01. We have our degrees of freedom, so it's 7 minus 2, which is 5. We get defined with the alpha of 0.01 two-tailed test. Your t-value will be plus or minus 4.032. You know I like to sketch it, and so over here, oh, that's ugly. Let's try it one more time. Still ugly, but a little bit less. This is going to be 4.032, negative 4.032. Okay, now where am I at? Got to calculate my t-value. So t equals r over the square root of 1 minus r squared all over n minus 2. My r values that we just calculated, 0.953 all over the square root of 1 minus 0.953 all over n minus 2, which is the calculation of the degrees of freedom, which is 5. I end up with the value of 7.034. That would be inside the rejection region, which is why we say we can reject HO. And then we say there is because it's inside here, right? There is enough evidence to conclude there is a linear correlation. Okay, next one up. Once again, we have to create a scatter plot, and we have to calculate your value of your line. So we'll go between two. We'll start over here. Nope, over here. Number 10. Same idea. Equals sum total thing. Let's call this the sum. I'm going to carry this over to all the remaining ones. Control B, bold them. Okay, equals times, carry them down, equals x squared equals y squared. Pull down the formula to the remaining blocks, pull down the formula to the remaining blocks. Okay, so that should be okay for me to use now. So now we want to use the formula of calculating our equation of our regression line. So m equals n times the sum of xy minus the sum of x times the sum of y. Notice the trend, all over n times the sum of x squared minus the sum of x. I have it written down as the sum of x, and I think it's squared. So we'll double check this as we go. Okay, so n is how many? 1, 2, 3, 4, 5, 6, 7. Double count. 1, 2. Okay, so it should be 7 times my sum of x times y, which is that 3, 4, 4, 1, 3.5. Minus the sum of x, 1, 5, 1, 6 times the sum of y, all over 7 times my sum of my x squared, 3, 6, 9, 3, 8, 2, minus the sum of my x's squared, 1, 5, 1, 6. Okay, now when I plugged all of this in for my m, I arrived at negative 0.090, and then we want to find our b, which is y bar minus m x bar. Well, y bar, it comes from the sum of my y's, so we have y bar equals the sum of my y's, which is 176, divided by my total number of 7s. So that is, let me do it in my calculator, 176 divided by 7. I ended up with that being 25.14, and it goes out 282. And then we need x bar, which is 1516 divided by 7. 1516 divided by 7, which is going to be 216.57. So over here you ended up with the 25.14 minus the number I calculated over here, negative 0.090 times the, where am I at? X bar, which is the 216.57. Okay. For this, I ended up with 44.675. Okay, let me know if you calculated an error in those calculations or you see that I did something different. Let me know. So over here, we now have the first answer being y hat equals negative 0.090x plus 4.4675. And then we got to construct that scatter plot. I'm just going to do a rough scatter plot, guys. It's getting where it looks like a hidden storm. And I just don't want to be here when it's doing that. Okay, sorry guys, I got a phone call, so I could not keep talking to you while I was doing it. So I just sketched a rough scatter plot. It is not very accurate, as you can see. Please try to do a better job than I did. And then when you try to do your regression line, or line of best fit, remember that you want to try to go up to 44, and where that would be on your y-axis, and then try to move down. And it's like a slope of a negative 0.1. That's a little tough to gauge, but just do your best. So that's roughly what that would look like. Our next portion would be plugging in the parts of the formula. I'm not going to do the whole thing. When you do it, it ends up being negative 0.984. We see this as a strong negative correlation. Okay, next one up. Part D apparently of this. Let me go to the next page so we can see it all. This is, what is the fuel efficiency rating for a car that you would predict with the engine displacement? Previously, I actually made you calculate ones that weren't inside our original range. This time I won't make you. So we see that 89 or 86 is not in the original range, so it's not going to be meaningful. So you can calculate it, it's just not good. Not meaningful, outside the range. Okay, so that means outside of our original X range. Our second part here is y hat, which is negative 0.090 times 1 times, let's try that again. I'm sorry, I feel rushed. I had somebody call. So, 198 plus 44.675, which is 26.86 miles per gallon. Over here we have y hat, which is negative 0.9090 times 286. Sorry, I keep saying the wrong numbers. I'm trying. Which is going to be 18.67 miles per gallon. And then our last one is not meaningful, outside of range. Okay, our next one is use the value of r to find the coefficient of determination and then interpret the results. Well, that's just r squared. So all you do is you take your r value and you square it, which gives you 0.30. And remember, r squared is the explained variance over total variance. So this tells you that 30.6% is explained of variance in y is explained, which means the remaining part is unexplained. So that's going to be 1 minus 0.306, which gives you that 69.4% of unexplained variance in y. Okay. We have 12. Construct a 95% confident our prediction interval for the fuel efficiency of an automobile from question 10, and if the engine displacement is 265. So this is where it comes from, your y hat. We still have that equation, negative 0.090 from before. This comes from your question, so 265 plus 44.6, which is going to give you 20.825. So to find our error, our formula is TCSE square root of 1 plus 1 over n plus n times x minus x bar squared, all over n times the sum of x's squared minus the sum of x squared. So once again, these are some calculations I did not go through with you guys. Some of them I did. So we have a formula for SE. I don't remember if we did it on this problem, but I would look it back up. I'll tell you the value I got when I did mine. So for my critical value, I ended up with 2.571, This is a 95% confidence level, so it's detailed tests, and then you have your degrees of freedom. And then over here, you have your SE. I calculated 1.476 times the square root of 1 plus 1 over 7. This should be a 7. 1 over 7 plus 7 times, and then this is my 265 minus 216.6 squared. So this is the x value in my problem. So that's the one that came from here. This is the x sub 0. And then it's my x bar. This isn't the sum of, it's just the x bar. So we calculated that previously, or we at least calculated the y. So this x is the same concept. And then over here we have our 7 again. And then the sum of our x's, which is 3, 6, 9, 3, 8, 2 minus 1, 5, 1, 6 squared. I have my calculations. I'm sorry, I'm not going to do them right now. You can let me know what you get. So it's 4.195. Then to find our interval, that's that y hat plus or minus e. So I do the 20. Go up here. Ends up being 20.825 plus or minus 4.159. I end up with 16.668 is less than y, which is less than 24.9842. So you can be 95% confident. I'm writing like a giant. Let me zoom in. That the fuel efficiency will be between 24.8982 miles per gallon. Let's just do the abbreviation, miles per gallon in PGs. And 16.668 miles per gallon. I should have written that in reverse. When the engine displacement is 265 cubic inches. Okay, number 13 says, just know how to do the online regression. I already posted a video. Izzy asked me to, and I did. And then number 14, our last one, these are really nice. All that you're doing here is just substituting in the values that you have. So here we have y hat equals 41.3 minus 0.004 times 305 minus 0.0048 times 375. And when you do that, you end up with 21.705. And down here, you're doing the same thing. You end up with y hat equals 41.13 minus 0.004 times 185 minus 0.0048 times 300. And that gives you the 25.86. Okay, let me know if you have any questions or if you see any errors. I will be not home tonight, but I'll do my best to keep checking and answering emails.